Okay, I'm almost finished with the ourLora project. I went back to my checklist here, looked at what I've completed. So I've got the notification capability going, shown in the last two videos. So these are the things I still plan to do. One is to manage the trigger frequency. So for example, the letterbox opener, if someone's opening that every minute, I don't want to get a message every minute. I'm probably not going to implement that yet just because I don't see a need for it. I'm only seeing the letterbox get open once a day. Most of the other monitors, like my ourBoutMonitor, will just be sending the data once every hour, so I don't have to worry about triggers firing off too frequently. So I'm going to put that on the back burner, but I've got the trigger log collection defined, so if I need to check when was the last trigger fired, I can look in the trigger log and put some sort of governance over how often messages go out. So I'm going to skip that one for now. These two here, POCs for the temperature humidity sensor, for the battery voltage sensor. These are really more to do with my ourBoutMonitor. So I'm planning now just to take ourLora, just get it completed, and then switch over to a separate project for ourBoutMonitor.com. And I'll probably start off showing how I migrate this project, ourLora project, to be a specific instance for ourBoutMonitor.com, and then do these ourBoutMonitor specific things like putting POCs together for the temperature humidity sensors, also building the actual ourBoutMonitor box and getting that into the boat. So I'll do that under the ourBoutMonitor. So again, I'll skip these two out of the ourLora project. Create time series processing function. So this is much like I did in ourProbes, where it looks at the time series data and creates another summary collection where it, say, summarizes by hour, by day sort of thing. Again, because of the nature of what I'm monitoring, things don't happen that frequently. I don't think I need to do this time series processing function yet. I'm not going to look at summarized data for my IoT devices, maybe at least until I get something like a temperature sensor outside that may be sending data every 5 minutes or something like that. So again, I'm going to skip that. I know how to do it. If you want to see how the time series processing function would look like, go to ourProbes and it shows the function that I set up on a cron job there to summarize data in time series. Another one, I want to add event trending charts and tables. So this one I will be doing in this video, so I'll show you not too much about how I actually put it together for, again, in ourProbes. And I think in ourDARs I've got examples of how you can get these charts put together. I'll just use the same charting tool, but I'll show you anything that is unique to ourLora for these charts. I'm going to have some different charts, probably things like a scatter chart. So that's what I'll cover in this video. I've already got a ourBoutMonitor.com URL set up, and the final thing I need to do is just clean up the base design for ourLora and roll back anything that I did that I think was worthwhile into the FVM Starter project. So hopefully this video might be the last one for ourLora, but like I say, I'm going to move a lot of the actual implementation of a dedicated sensor for my boat into ourBoutMonitor.com project and blogs. Okay, in this video I'll have a look at the charts and tables, which I call views, which are views over an application's events, or a certain event for an application. So in the data model, I've got the views collection, which at the moment looks like this, at least in the model. Main changes, I work on this, but the idea is I can define a view for a particular sensor reference, which is a sensor that is in a particular application, and I can define a view type, and the view types are shown here in the enum is the could be a table, could be a line chart, or could be a scatter chart. So usually you'd use a scatter chart for things that just have discrete values, like a letterbox opening and closing, or even use a table for that. But something that could have a lot of different values, you might use a line chart to show trends in those values changing. And the only other thing I should have to do with, after I've created the views component to show the view, is tie it into the roles that I have in the system. So views will be about the only other function in the system where someone who's not an administrator has access to. So if you're a user for a particular application, when you come into the system, you'll be presented with the views that application as things that you have available to you to look at. So you can see the views, say, for the letterbox opener, even if you're not a administrator for the that particular application. So let's try it out. So this is 2 or 3 days later. I actually spent some time. I actually changed from using the chart package that I was using in our probes and our checklists, which was called Swimlane ngx-charts, over to using one called Angular Google Charts, which is based on Google Charts and has an Angular layer over the top of it. And main reason for doing that was I was finding that the Swimlane charts were not handling updates that well. It's really complicated getting them to update a chart when things like observables or subscriptions to observables updated. They turned out to be a couple of meg larger than the Angular Google Charts, and also because it's based on Google Charts, you get all the support of something like Google Charts, which tons of people use. And the way it used the actual data format across different types of charts worked out a lot better for my application than what I could do with the Swimlane charts. So I'll probably go into a little bit of the coding in this as well. So let's have a look at it. So I'm logged in. So I added this My Views menu item. So whether you're an administrator or a normal user, you get to see all the views that are available to you as that user. So if you're a user associated with an application, then you get to see the views that are available on it. Let's have a look at these mailbox ones. So what it looks like when I click on one of these views. So let's look at this battery voltage history. So it shows me a line chart in this case showing the battery voltage in my mailbox sensor as it changes. So it's close to 3 volts, which is good. If it gets down to about 2.5 volts, it's about time for changing the battery in the sensor. So the nice thing about the Google Charts version of this is it's easy to change the chart type. So I can change it, say, if I want to see it as a scatter chart, or even if I want to see it as a table of values, I can very easily just flip the chart type and it redraws it, because the actual chart data is consistent between all those different types. Also, I can do things like, once I've rendered the chart, so let's go back to a scatter chart, I can do things like change parameters for that chart. So if I just want to see 10 data points, or the last 10 data points for battery voltage history, and we'll change that back to a line chart, then I can simply do that and it'll refresh the chart. I was finding that was really hard to do with the Swimlane charts. One other thing to look at is just how those things are defined. So if I go to my mailbox application, you can see that the user who is associated with it is myself. I could add other users and they would then see it on their list of available views. And I think I've shown this before, but this is where the views get defined. So if I look at this battery voltage history, it has a name, a description, the default view that it's going to show when you go into that view. So by default it's going to show it as a line chart, but again, once you're in the chart you can then change the views. And then the sensor that should be incorporated in the view. And that's the other thing to be aware of this. If you have a application that includes multiple devices that have the same sensor type, so for example you may have an array of temperature sensors that are all the same sensor type, and the sensor information you're getting is, say, temperature in that case, then the way this works is it'll collect all the events to be charted in the view of everything that has that sensor type. An example of that might be if we look at my views for curl. So I'm collecting for my test curl sensor, I'm actually collecting event data from two devices, this curl test 1 and curl test 2. And again, because of the nice way this charting program works, it can actually differentiate between those different data series, show labels and things, do all the good things that you'd want it to do. Okay, let's have a look at the code. So I'm in the My Viewer component. That's the one that shows the charts. So first, the HTML template. Most of the HTML in here is around setting up the options selectors at the top of the page, and then this part here is the actual HTML that defines the Google chart, which the Angular Google chart component's going to talk to. So really simple, other than setting the type, passing it the data, telling it which columns to use, any special options like where the legends go. I can set dynamic resize, so it resizes as the page gets resizes, and then I've got a class over the whole thing, so I can apply some CSS rules to it. In the actual code, I'm using a lot of async and awaits in here, so I get all the data that I want before building a chart data array that has all the data for the chart in the format that the chart wants to see it. So let's drop through here. So the main thing that happens is calling this chart processor with the view and the application ID of the chart. We drop into that. We set the chart type based on the view type setting. Clear up some of the arrays, then this is the thing that collects all the events that are in scope. So it sets up an observable called events $, and then subscribes to that observable of all the events it retrieves. And then for each of those, it'll start building up an array of rows that represent each one of those events, and then it'll build that as a array I call raw data, and then I have another call here to raw to chart data that actually converts that raw data format to the format that the Google Charts programs uses, which is this code here. This is a pretty short piece of code in the end compared to what I was having to do with the swim lanes and sort of the hoops I had to jump through to get things to display at the right time when the observable and subscription finishes, which wasn't always hard to determine. This works out a lot better, and I think the actual Google chart seems to respond to changes in the chart data array as they happen, so I don't have to kind of worry about only showing the chart when the data array is composed. About the only other thing in here to be aware of is those two options at the top of the component where I'm passing the view type and the number of events to get. Whenever that changes or gets updated, I call on option change, and that's what calls this chart processor again to go and retrieve the data with the new parameters and show it in a chart with the new parameters. So that's about it for the ourLora application. After this, I'm going to start a new project called ourBoutMonitor, and I'll sort of continue what I was going to do in ourLora, but specific to a boat monitor. So I'm basically going to copy the whole project of ourLora, do a bit of renaming, and then carry on, but have it specific as a boat monitor, especially since I'm not using ourLora or not using LoRaWAN for networking now. I'm going to be using some sort of e-networking to get the data from the boat to this back end.